I'd like to start with the subject of today's webinar, using Office 365 as an example for an internet authentication provider for authentication of users in OpenEdge GUI applications. I'm Mike Fechner. I'm going to briefly introduce myself, and then I'm going to let Peter introduce himself. I'm working as the founder, director, architect in modernization projects, product manager, developer, whatever role you want at Consulting Werk. I'm located in Germany, in Cologne. I spend a lot of my time in either the work on our products, on things like object-oriented design, integration of OpenEdge applications with whatever, modernization, very often modernization of the user interface, but modernization is more than just user interfaces. I use Progress for more than 30 years now. Started with version 5, seen, all the changes in the OpenEdge world since then. And every now and then, having seen version 5 helps me when dealing with version 5 style codes that may still be around in version 11 or 12, and guiding customers through modernization strategies, helping them find modernization strategies. I like being around in the OpenEdge community. I like to speak at conferences, being in forums, etc. With that, I'm going to pass to Peter, who joined us last year. Peter, you are still on mute.
Somebody had to be on mute. That's better, I think. So Peter Judge, I'm been at Consulting Werk coming up for a year now. It's like 11 months. Before then, I was at Progress for a very long time. I've been working with OpenEdge, APL, 4GL, not quite as long as Mike, but certainly certain amount of time, a long time. And more lately, I've worked on PaaS-OE stuff, HTTP client, that aspect of it. Like Mike, enjoy being at conferences, talking at conferences, being on Progress communities, those kinds of things. And at Consulting Werk, I do, I don't know if it's what kind of split it is, but work on the framework development and design, as well as helping customers with a variety of things, including moving to PaaS-OE, build pipelines, all sorts of fun things like that. I'll give it back to you, Mike.
Good. So Peter can be glad that he has at least 25 years of experience with OpenEdge, because with that, at Consulting Werk, we don't refer to him as a junior anymore. Have you earned your senior already? I don't know. Anyway, so at Consulting Werk, we support organizations developing in OpenEdge. Our focus is really the development side of things more than the operation of OpenEdge applications. Also, we support customers every now and then. It's OpenEdge and related technologies, that may be related technology from the Progress product portfolio, but also from other technologies. .NET as a front-end technology, Java for integration, various web technologies for browser-based front ends. All those are technologies that we're using or helping our customers to introduce them. Our main office is in Cologne, in Germany, and we have a team of 18 people working from all over Europe. And Peter is representing us in the United States now. We're working accordingly with customers all over Europe, North America, Australia, and South Africa. And what we really do is we provide consulting services, helping our customers with our knowledge or with our hands on the keyboard, and are a vendor of development tools that can support customers during modernization. One of them is the Smart Component Library framework, which we'll see parts of it in this webinar, but this is not really a webinar about it. So brief overview of some of the Progress or former Progress products that we're supporting our customers with. And beyond that, there's some products which are related or can be used together with OpenEdge that we also frequently help our customers in adopting them. But the focus of this webinar is really on using Office 365 as an example, OAuth2 identity server or service to authenticate an OpenEdge or a user for an OpenEdge GUI application. I'll start with an introduction, then Peter will be introducing you to the dark side of it, as the theory of OAuth2 and the various bits and pieces that belong to that, what is required on the Office 365 side to configure an application there, to have the foundation for authenticating users. And then I'll walk you through to the solution or the two solutions that we have developed to use that in the context of an OpenEdge GUI application. So why is that relevant? Well, there's probably no business application that does not require to know who the user is. So authentication is very important for business applications, maybe for auditing purposes that you need to keep track of who the user is, or it may be for authorization. Not every user may be allowed to do the same set of functions in the application. And very often in OpenEdge applications, or generally in desktop applications, you authenticate a user with a username and a password, and the username and password is stored in the application database or any other storage, but typically in a database. Might be the OpenEdge world, the underscore user table, might be an applications user table, or whatever, and you know what you're using there. But within a distributed application, it might be that from a single front end, multiple application backends need to know who's users, and that in a trusted fashion. Trusted fashion means that not just the front end application tells to any web service, hey, the user is Peter Judge. Believe me, I'm promising it to you. The other web service needs to be able to trust that information. Keeping passwords, the passwords that the user in the morning used to authenticate to the one front-end application, keeping that around and passing the passwords then with all the requests to the other server, that's simply a no-go. You should not be keeping passwords in motion for longer as needed. And in the OpenEdge world, Progress has established around the early versions of OpenEdge 10, when auditing was introduced, Progress has established the client principle for that purpose. So there's an identity token, which is just a secure, sealed, signed, potentially encrypted bit of information that tells another application who the user is. Another application, because the first application has verified the user, probably using a password and a username, and then that other application has a way of saying, oh, if it's coming from that application, I do have a trust relationship with this other application. If that application tells me it's Peter Judge, I believe it. Carrie, I'm going to mute your microphone. So that works well between various backend servers in the OpenEdge world, so especially app servers and databases. But unfortunately, in today's IT world, we're not just dealing with OpenEdge. Very often, there's integration with other services, and a more complex application becomes a combination of different backend services. And then in this non-OpenEdge world, we need to deal with open standards for entity management. And one of these standards is OAuth2. Typically known from web applications. And because Progress has with PathOE and top-class web application server, PathOE also understands OAuth2 for authentication and authorization. So that's a great fit as well. So the other thing is security demands of IT organizations are typically growing. I don't think anybody has experienced that security demands are relaxing over time. And this is more critical for web applications because they may be used in the open field, and desktop applications are more used in private networks, but also in private networks, security demands are growing. One demand that we've heard from a couple of customers is that they want more than just a password-based authentication for their desktop applications as well. So things like two-factor authentication, where together with the username and password, the user needs to provide a one-time token, one-time password that could be provided from an authenticator application or could be received from a text message or email, and only has a very short validity. And that provides an additional means of security because it's verified that the user has received, using a predefined method, that one-time token that's only valid for a short time. And that provides additional security because, yeah, well, another human being that has stolen a password does not have access to getting this one-time token at the same time. And the next level of security might be adding a biometrical identifier, something like a fingerprint, an iris, or a face scan, which is typically provided using a mobile phone because that's the device that everybody has and that provides the scanning capabilities for that. And all these things, which are constantly getting more and more complicated very fast, are typically things that a business application developer has no interest in keeping up with. That should be something that other developers take care of. And that's where Office 365 may come handy. Office 365 is widely used in businesses for email, SharePoint, other applications. Other businesses may have a preference for the Google suite of applications. So you can replace Office 365 here very easily with G Suite or Google for Business or Google Workspace. Google seems to be naming this every time I look at it. And that also means that every business user typically has an account in one of these web-based services already. And they are also interested in integrating with other services, with other applications, and so they provide the authentication capability as a functionality that other applications can be using. In the case of Office 365, that's based on Azure AD. Azure AD should not be confused with Active Directory. It's just Microsoft's marketing way of who everybody knows our Active Directory. So let's use that name for something completely different. In the details, and Peter is going to tell us about that in a second, that then extends the OAuth2 based authentication into an OpenID Connect flow. So now how can that look like? Well, I do have an OpenEdge GUI application, and because I will need my phone in a second, I have here a remote display of my mobile phone. And I'm gonna start an OpenEdge desktop application. The desktop application is based on GUI 4.net, and using one configuration, I can start the desktop application with a traditional login prompt, connecting to database. It's all fat client, no app server needed here. It could be working with an app server if we want to, but still many desktop applications are based on fat client connections. So I'm getting a standard login dialog. Using a different icon on the desktop, I'm starting the same application with a different authentication configuration. And then what the application shows as the login prompt is a web browser. And we're using CefSharp, which is basically Google Chrome as an embedded browser. Oops, what did I do? I started the wrong one. This one. I'm using CefSharp, which is based on the Google Chrome browser. Google Chrome, or the foundation of Google Chrome, is open source from Google, and CefSharp is a .NET port of that browser. So it basically allows you to use CefSharp or Google Chrome as a browser in your own desktop applications. And even though this is GUI 4.net, all the user interface controls you see here are .NET controls, it is possible to use it with a classic OpenEdge GUI application as well. So in this browser application, which is blocking the access to the application, I can log in, and now the first factor kicks in, which is my password. So I'm pasting my password here from my password manager, which is running on a different monitor. And now the second factor kicks in. I am now being prompted, and you can see that on the phone here. I'm being prompted to accept the connection, and I need to confirm the number I see on the screen. So I type in 39. That was the second factor, and now I'm being prompted, that is for security reason not shown on the screen, to scan my fingerprint. So now with these three authentication factors, I'm signed in, and the browser window asks me whether I want to save this login on my desktop here, and I've chosen not to do that for demo purposes. So now I have logged in, and I could look in the log file of the application. We see there are a couple of messages which I will refer to in the later course of this presentation about the JWT token that we've received from Office 365, which basically carries the user information. And with this, I'm going to pass to Peter to provide us some of the foundation of OAuth2 and related stuff.
Yeah, so what did you call it? Dark magic earlier?
The dark side.
The dark side. Yeah, so OAuth2 is surprisingly to a lot of people, a standardized protocol for authorization. So what does that mean? It means that you use it to, as Mike pointed out earlier, it's a mechanism of giving users identities permission to do something, kind of out of this standard thing. So when you log in somewhere, you get permission to do a thing or multiple things. OAuth2, as I said, by itself is an authorization protocol. There's an RFC. There are many more. It's quite dry to read. It's very complex in a lot of ways. There's a lot of what they call flows, which is kind of the process of what kind of client you have, how you log in, who sends what to whom, what that means in terms of security of that token. Obviously, authorization depends on authentication, so you can't give people permissions to do things unless you know who they are. And to do that in Azure AD is a additional open protocol called OpenID Connect. Very well known. There are very many, we'll look at a list of them a little later, very many providers of OpenID Connect, identity providers they're called. And OpenID Connect is what is used in Azure Active Directory to provide the authentication part. So that whole dance you saw where Mike logged in on the browser, it came back and it said, you know, add your factors, do you want to stay signed in? All of that sort of stuff is part of this authentication flow. And the invisible, to us anyway, bit at the end was Mike had signed in and was issued a token, what's called an ID token, identity token from Azure Active Directory. And that now says two things. One, that he's authenticated, and two, that he has a certain set of permissions that he is allowed to, of things that he's allowed to do. There are other authentication schemes you can use or protocols you can use also within Azure Active Directory. SAML is another one that's very well known. We won't talk about that today, but OpenID Connect is the mechanism, is the protocol or the scheme that we will use, we will work with. The ID token that gets issued, we'll look at a little bit of detail what that looks like. And that basically says it's got a claim. Talk about what a claim is in a sec, but basically says this is the subject, this is the person we are validating that they are authenticated. The next
One
slide,
thing to mention here before I go to the next slide, the terms OAuth2 and OIDC on many websites, blog articles that describe the whole thing, they're typically used interchangeably for each other. I mean, in the theory, they're different, or they're different sides of the same metal. but they're very often used as different names for the same thing.
Yeah. So what do we get? Mike showed in the logs a little earlier a bit of gobbledygook, what looked like gobbledygook, and that's what's called a JSON Web Token, a JWT, a JWT, and that's what's issued by Azure to the application or to the client. And that says a couple of things. It's got kind of three parts to it: a header, a payload, and a signature. There's also a spec for that if you really feel like, getting asleep by reading all of these specs. But basically what that says is it defines some data. The payload has things like that claim. It says this is Peter, this is Mike, whoever signed in. The signature allows us to verify that that's true. Otherwise, anybody could just publish these things, right? I could just create one in Notepad and send it to Mike and say, hey, or send it to the application and say, hey, I'm Mike, right? But without having some kind of a verification mechanism, which is these public key mechanism coming out of what's called a JSON Web Key Set, another acronym, right? More acronyms, JWKS. And those are provided by, in this case, Azure Active Directory. So they'll provide a set of public keys that can be used to validate or to verify that this token is legit. Because it's an HTTP thing mainly, OAuth 2 was kind of designed with HTTP client server stuff in mind. So it needs to be passed around. And so it has a URL safe form. And you can see in the bottom right here, kind of this red, blue, and green dot delimited thing. And those are just three pieces of base 64 encoded information. A header, which has got some meta information about the signature, the payload, so what it says, usernames or IDs, things like that, and then the signature at the last part. These get passed around in a variety of ways. Like typically, it gets passed as an HTTP header, the authorization header as a bearer token. That's the most common use case you see, and that's the one that PAS-OE supports natively. But it may also be passed as part of the URL query string. It may also be passed in a form encoded body, right? Could be passed as just a plain text body. The specs are not 100% solid on exactly how you must do it. There's a lot of flexibility in how these things should be passed, and so that also becomes part of the the client's job, which is receiving that token and doing something with it. And we'll see that a little later.
But important here, it's just base 64 encoded. That's not encrypted. So it's like a password. Everybody can read it. Everybody can read your nationality, which at a border is like a claim. Hey, I want to go through the short line into the country instead of going through the long line. And the signature is like the hologram on your passport, which should prove that it's not a fake ID card. It's a true passport.
Yeah. So speaking of claims, so claims and scopes are things that belong to JWTs. A claim is, and this is from one of the multiple specs, it's a piece of information asserted about an identity. So things like email addresses or usernames, client IP addresses. We'll see a little later how we can get some of these out of Azure Active Directory. But if you think about it, if you've worked with a client principal, there's properties associated with the client principal, and they are immutable pieces of information about that client principal. So like I said, email address, there's a thing called preferred username. That's also kind of an immutable piece of information. Scopes are similar in that there are additional bits of information added to a JWT, but their purpose in life is slightly different, and they are there to authorize or allow access to resources. So, can I read a certain piece of information? Can I update a certain piece of information? All of that sort of stuff, similar to client principal roles. So that's kind of their purpose in life. We can click next. I've touched a bit on, you can see a JWT token and a client principal, they kind of have the same purpose in life. They both are containers, trusted containers, right? Whether the trust is through a seal or through a signature, containing information about a particular user. JWTs are open standard, public, everywhere on the internet. Client principles are very specific to OpenEdge. Yeah. Oh, and the other most important part is we can exchange a JWT into a client principal, which in our OpenEdge world is really important because we can now say, okay, we've got a trusted token representing a user in an ABL consumable form. So we can go next. As Mike mentioned, a JWT is pretty much plain text. This is a decoder, if you will, on that website, jwt.ms. It's quite a nice one because it both decodes it, kind of the top, you put the token in, it shows you the header, the payload, and the signature, but it has a second tab that tells you what those mean if it can find those claims in a spec somewhere, which is really quite handy for figuring out what they're meant to be, because a lot of them are just 3 letters long and they are impenetrable unless you have this. Thanks, Mike. Yeah. So how does this kind of flow work? So from a client perspective, the desktop application we saw earlier, it authenticates against the Azure Active Directory, does its dance, issues you a token back. We can take that token and then pass that on the authorization header to the PAS-OE server, which is what's called a resource server. And the resource server then validates, verifies that that token is legitimate using these JWKS information that it has. And so now it's happy that it's got that you are who you say you are, and it can return you the data, and you are now logged in. So I think that's the flow. There's a whole bunch of other ones. You can see a lot of sites like this. Microsoft's got at least 3, LinkedIn, GitHub, and Azure Active Directory. Google's got probably more than one. Facebook's got many. There are tons of these out there. And the point of OpenID Connect was to allow people to plug in their own stuff in the back, their own authentication providers. But generally, that's not a game you want to be in. It's complicated. It's hard to do well. Looking at the size of these companies that run these things, you generally want to piggyback off of their, 10,000 software, security engineers that they have running there rather than your own. I think that was...
And I think if you decide which one you use for authenticating your users, you need to look at who's your audience. I mean, that's what I said in the business world. Most users either have a Google for business or an Office 365 login. We at Consulting Work, we use a graphical Git client called GitKraken that uses GitHub as one of the potential authentication providers using OAuth2, and that makes a lot of sense for a Git client to say, okay, well, we use GitHub as for authenticating. So you pick those for your audience, and probably in a business application for in-house users, Facebook's probably the least you would care about. That would be more for web shop when you want to be having easy login for a wider audience of users.
Yeah.
So now comes the dark magic.
Now comes the dark. So we will there. This next section's got a lot of screenshots of how we've set up what's called an enterprise application or a registered application in Azure. This kind of slide is the most important of them. We can skip through some of them quite quickly. But in Azure, there's this concept of enterprise applications and then app registrations. And that's kind of the group you use to configure the OpenID Connector OAuth2 stuff, right? That's got things like the groups of users that are allowed to see it, what kind of a flow it is. We're using a web API flow. And very importantly, the redirect URL. So once that whole authentication dance is done, where does it send the token? And that's the redirect URL. And that's very important for us because we need some mechanism of getting that token. This kind of to and fro is also somewhat why it's difficult to do this natively in ABL, because the ABL does not have an HTTP server that can sit and listen for requests coming back. To configure PAS-OE, to make it be able to authenticate and validate JWT tokens, JWT tokens, we need 2 bits of information. Firstly, the client ID. So each client has a unique identifier. These are just GUIDs typically, and this JWT URI, which is where the public keys are kept for the signatures of the JWT tokens. We get a whole bunch of stuff for free, multi-factor authentication. You know, Microsoft's changed that in the last couple of months from kind of a thumbprint and type in a code to this 2-digit number, and no doubt they'll change it to some passwordless thing in the future, like Google's starting to do. You can configure things like this: keep connected, keep signed in pop-ups. There's a whole bunch of darker magic inside of Azure Active Directory to let you control that whole side of it. But that's kind of the most important thing. Just this screen is confusing at first. Again, within enterprise applications, you need to do an application registration. Don't ask me why the UX is put together like this, but finding some of this stuff can be tricky. Thank you.
And once you found it, be assured that 3 months later, they're changing it again and again and again.
Yes.
But they all do. Google does that, Facebook does that, LinkedIn does it. They keep updating it. This website, maybe that's a bit of information that's useful. If you are user of Office 365, the administrator of your Office 365 tenant has access to that through the admin web interfaces.
Yes. Just kind of where to get stuff. The important things here, the authentication flows, is 3 bits in here. One is the flow, so you can set up as a web API, you could set it up as like a JavaScript client, you could set it up as different types of clients. ID tokens we have to use with PAS-OE. It doesn't support the access tokens. Maybe it does in the most recent releases, but certainly in the LTSs it doesn't. And you can support the account types, what users are allowed to go here. So we could say, you know, that anybody in my whole Azure AD directory, and we can limit who is allowed access to this client. So just more gates. Thank you. The next one, again, we can click through this. I'll just talk through this. Setting up a certificate. So you can upload a certificate, typically a self-signed one, and that's used to sign your JWTs. Next. Additional claims to be added in. So on the right, you know, we're adding email addresses. I mentioned IP addresses, preferred username. That's pretty much what you logged in with. So Azure gives you the option to log in with one name and have a different email address. This gives us our real username. And we need that because the subject, the subclaim that is sent is this weird and wonderful identifier that has no relevance to us. It's just an identifier for the JWT. We can add roles, user groups, stuff like that from Azure's roles as well. Again, endpoints we need, the application client ID we need. You can click through. That metadata document is really important to us. Click through, because that gives us our JWT URI, which we need to use to sign or to verify the signatures. So that is that step. On the configuration side of Office, there's obviously a lot more to do. That's kind of your basics to get yourself working. You know, but there's a lot more you can add in terms of roles, in terms of claims, in terms of signatures, all that sort of stuff.
Well, thank you, Peter. And I'm going to walk you now through the AVL solution, so making that work with an OpenEdge GUI client. So we integrate the OpenAuth authentication flow or the OIDC flow into a GUI application, which could be a classic AVL GUI or a GUI for .NET. Works in the same way with client networking, so the FAT client or with a web client, which is a SYN client. We use for the integration CefSharp. I'm going to talk about that in the next couple of slides, which is just our preferred web browser for integrating with OpenEdge applications. There was an ActiveX-based web browser that people have been using also in AVL applications for decades that used to be based on Internet Explorer. There's now a new component from Microsoft based on the Edge browser, which, well, compared to CefSharp as an alternative .NET component is much younger. Well, CefSharp is very flexible for us. We know we have a modern browser. We have a browser that's updated whenever there's security flaws. So that just gives us also a very good feeling of what this browser component, even though it's a little bit more work than using one that Microsoft would provide us. So we have the web browser that drives the user through the flow of authenticating. In the end, we're getting a token, but then we need to make sure that we can trust the information in that token. We can always read it, but then anybody else could be providing us like with a fake passport. So we need to verify it. So we've developed two methods of verifying the JWT token. One is using PassOE, because PassOE you can authenticate with a JWT token at PassOE. So you can do any time a request against PassOE with this bearer token, and then PassOE will on the fly translate it into a client principal magic. But that would mean we always need to have PassOE as an app server, and that is something which not for all OpenEdge GUI applications is already there. So for that case, we have written an ABL method or an ABL class with number of methods, and they use components of the .NET framework. Since OpenEdge 10.2, so since over 15 years, you can use any .NET component in ABL applications. With the oldest of the two LTS releases, 11.7, that is a very well-established method. So using .NET there is something which is, I consider that just a natural extension of the ABL. And I'm going to show the code for that in a bit. So with these two methods, we just have a very wide fit. So applications that are already app server based, that already using PassOE, they may already have OAuth2 in the mix to allow third-party applications that use REST services to authenticate against Pass. And with the ABL.NET-based verification of the JWT token, we also have a fit for those applications which are just ABL client-based. If or if not, in the latter case, we actually create a client principal ourselves based on the information taken is something. Well, if your application needs it, maybe for auditing purposes, etc., then we would do it. Otherwise, we might not need a client principal. We have various authentication settings. Basically, all the data that Peter showed in the Office 365 configuration about the JSON web key store, for instance, and the audience and all these bits, we need them for our authentication too. We have that in various of the config files. And if you use the PassOE for the token exchange, then the URL of that PassOE for that connection is also part of the configuration settings. So CefSharp, I mentioned it earlier, is part of the stack that we're using here. So CefSharp, or Cef stands for Chromium Embedded Framework. So Chromium is the open source version of the Google Chrome web browser, embedded because it's meant to be not a standalone browser. It is a browser that is meant to be integrated into an application. And as a framework, it's something that's targeted to application developers. And CefSharp is the C# port, so it's .NET. And as I said a minute ago, .NET is just a natural extension of the ABL. We can use CefSharp here too. It's the BSD license, so an open source license. It provides a WinForms, that is the UI technology in .NET framework that's the best fit for OpenEdge GUI applications browser control. And it is just a de facto standard for embedding a web browser into applications. So if you look at the list of applications there, that's just a very small snapshot of applications that are using CefSharp for similar purposes. It is not dependent on Google Chrome. That's also great. So the application provides CefSharp as an embedded browser. And you have no dependency on anything installed on your Windows PC. The way we use CefSharp is we use the source code. We download it from a Git page, but there are also binaries available. The reason why we use the source code is we need to write a small add-on .NET component that deals with the fact that a web browser typically uses multiple threads and the ABL GUI client is only single-threaded. So we need to work with thread synchronization. And if we have the source code of the browser, that just makes the debugging of our add-on assembly easier. CefSharp is always very up to date. So this morning I looked at what is the current version of the Google Chrome browser I've installed, and it's a version 1.14, which was released on the 23rd of May this year. On a website which is actually hosted by Spotify. So Spotify is not just using CefSharp, Spotify is also an active contributor to the CefSharp ecosystem. I can download binaries for CefSharp in exactly that same version of Google Chrome. So it's really, for those who are really security concerned, being up to date with the browser is very, very important. And I should have updated the slide because the version 88 was the current version 2 years ago when I did my first presentation about this topic. Yeah, well, we have chosen, because we have the experience in-house, we've chosen to build CefSharp ourselves. So we have a .NET solution there, which is just the same as a Progress Developer workspace for .NET developers. And we download the source code and we compile it. One thing we need to consider, since CefSharp and the Google browser are actually C++ based and not .NET, we're just adding a wrapper, a .NET wrapper on top of it. CefSharp is you need to build it separately for 32-bit Progress clients and 64-bit Progress clients. Hopefully, you're in the lucky situation that you can always use a 64-bit Progress client and don't have to worry about 32 anymore. But if you have, then you may need to be shipping the 32 and the 64-bit version as part of your application to users and using the configuration and point to which version is being used. So we use that for this authentication user interface, and when the Office 365 authentication flow is done, Office 365 actually tells the browser components through a redirect instruction to navigate to another web page. This is a web page which we're not using, because once we know we're being navigated, we redirect it to another web page when we know we had a successful successful authentication. So we handle that using the before browse callback provided by CefSharp. And with that before browse callback, we can read the URL that it's forwarding to, and part of that URL is the JWT token. And I can show how that is using. So from the log file here, I'm logging in the client log file here, the forward URL that we have detected that way. I'm copying that into Notepad just to get the garbage out of the way. And this is like that. So, and when we read that, we see that in the forward URL, there's an hash ID token equals. And that's where the JWT token starts, and it ends here at the ampersand. So that is the encoded JWT token. So and I can copy and paste that into either the JWT IO or the JWT MS webpage that Peter has introduced. So I just paste this in here. And we see the three colors that Peter showed. We have the header. The header introduces the client to the key that was the key to the ID of the public key used for signing it. And here we have the payload, so that's the actual data. And as part of the payload, we see the preferred username. So that's basically my login username. And very often in these internet-based authentication scenarios, an email address is actually used as the username.
Sorry, Mike, before you go off there, just to point out the sub claim, a couple of lines down from your preferred username, that's what Azure thinks your username is, which is just meaningless to your business application. That's an internal thing that Azure knows about, but not the application.
Yeah. So, and that is just coming from a redirect URL that we have intercepted or got from this browser callback. So I'm gonna skip that bit because talking a bit more than we were planning. The JWT auth form, we're gonna do a bit more code review later. So here we have the before browse callback event, or the progress and OpenEdge method that gets a reference to a number of objects, but one of these objects is an event argument. And in there we see we have a request URL. And when that begins with the expected redirect URL, then we know the authentication is finished. So that is the URL of the application that Peter had configured in Office 365, and Office 365 believes it's authenticating for a web application, so that's why it's an URL. That doesn't have to be an URL that really exists. So OpenEdge is, Office 365 is not verifying that that's a legitimate URL. It just knows that, okay, when I'm done with authenticating the user, I'm telling the browser, go there, and we're reacting on that by saying, okay, well, if we're forwarding to there, then we know authentication has been successful. As part of the URL, we have understood how we can read the JWT token, and yeah. That is then the entry point for us to validate the issued JWT token. So that's basically what I had done live earlier. So I look at the forward URL, I take the JWT token out there, and that's just a little bit of string manipulation. So that's integrated into our framework, but that can easily be integrated into any other OpenEdge application in a similar form. We call into a login method of the session manager, and we're actually passing the redirect URL as the username. That was just to fit with existing interfaces. We call into what we call the JWT authentication service. That's the client side of validating the JWT token based on the URL. And as part of that, we pass the JWT token. The JWT token is passed as using an ABL class. And now, like promised, I'm going to walk through some code. I'm going to start with the JWT authentication service that is getting a method to authenticate or validate the user based on credentials in an OpenEdge class. And here we see the log message that I've seen earlier in the log file. The first method here extracts the JWT token as a character string. It's base 64, so it's just did Peter call it? ASCII-friendly characters. So that's just string manipulation. We look for the ID token, and we take everything from there to the next ampersand, and that's then our parameters for just using substring to get the character JWT token. So then we have an ABL class called the JSON Web Token Parser, and I know we've changed our naming standard from JSON Web Token Parser into now just JWT. That's something that we have to reconsider at some point. And that's pure ABL. We take the token, which in theory can be longer than 32K. So we're using longchar here in the coder. We're using the entry function based on the periods to separate the header base 64 string from the payload base 64 string. Then we're just using the ABL base 64 decode into a mem pointer, copying the mem pointer into another longchar, and using then the JSON parser of the ABL. The JSON parser of the ABL could also be working on a mem pointer directly, but we're using this extra conversion into a longchar because it's friendlier for logging it in a log file. And then some of the known claims in the header and the payload we are assigning to an ABL class, and that is just gonna make it easier. So we have an ABL class, JSON Web Token header, JSON Web Token payload with these known properties, but it is very common, and it's actually part of the JWT specification, that you can have additional claims. You can have private claims, you can have public claims. There's a website where you could easily register a new claim as a new standard. But this is basically the basic, and like Peter said earlier, the subject is meant to be the user identity, and the preferred username that Microsoft is using is actually a private one, because it's not part of the official JWT token specification. But that is expected. Yeah, and the JWT authentication service, once it has the JSON Web Token, then looks based on a configuration. We have a configuration setting that tells us whether we should validate using the .NET framework or the token exchange service. Token exchange service is a PASOE-based variant that I'll introduce in a second. So far, not a lot of code, and the good thing it remains that we actually don't need millions of lines of code to do this. So let's look into the token exchange service based on PASOE. And that converts and verifies the JWT token, based on the call into PASOE, and well, there's the Spring Framework components that are used by Progress to put together PASOE are doing much of the hard work. And it's based on the client-side component that basically just wraps a call into PASOE using the ABL HTTP client, which is a component in OpenEdge that Peter must accept a lot of responsibility for, because he was the initial developer of that component. And then on the PASOE side, we have a web handler, which is an ABL class, which accepts an HTTP call. And in this case, it just returns the provided client principal based in base 64. So when putting together a solution, I don't know, whenever I've used before that so much base 64 encode and decode. It's we got a little bit base 64 crazy. The conversion of the JWT token into the client principal, that's not anything we have to program or develop. That's just something that you need to configure in PASOE. So the only thing we do here is that the client principal that PASOE provides us, based on what it always does with OS2, the only thing we do is we return it in, again, a simple ASCII compatible form, base 64 encoded data, so that we can return it to the client. And we've developed that as an additional ABL web application on PASOE, so that runs then besides the web application or the ABL web application that PASOE is used in this context mainly. And the configuration here is, we've taken the OEABL security.properties configuration file that, if you've ever looked at security configuration for PASOE, normally this file is a couple of hundreds, maybe thousands lines long, because of many different authentication types PASOE supports, all being in one file, and lots of comments. What we recommend is, once you know what configuration you want to do, you take away all the lines of that file that you don't need. That just makes it easier to read what it is. And one of these components there is in line 12, the reference to the JWK, so the JSON Web Key Store or Web Key Set. So that's a website that Microsoft hosts, and that's where Microsoft publicly provides the public keys used to sign. So Microsoft uses a private key to sign the JWT token, and we can use the public key to verify the authenticity of that. And that's the majority of the work is to put together this configuration here. Then we have the client-side method, and here we see it's using the OpenEdge HTTP client class. So we create an instance of the client. We prepare a call to the token exchange service URL. That's the URL of the PASOE web handler. We add the authorization header with the bearer prefix and then the JWT token, the base64 encoded one, and then we just make a request. We execute the request, and we expect that we're getting a JSON object back, and we further expect that within the JSON object we have an attribute called token, which is base64 encoded, so we can use the get raw method of that. That's an ABL raw data, and we can use this ABL raw data then on the client side to recreate the client principal. And from there on the client side, we have a client principal that's sealed by PassOE. So if you would be issuing that client principal to a multi-tenant OpenEdge database, the database would be able to trust that identity and know, oh, this is Peter Judge, and Peter Judge has access to the tenant consulting wing in the database. So to obtain then the authenticated username, we can use the get property method of the client principal. In this case, the client principal, which is normally in handle-based object, but Progress also provides a class wrapper to it. But both of them, they have a get property method, so I can ask the client principal for this get preferred username property. And yeah, so the ABL HTML can makes a call. I think that's really just what I was introducing when I was going through the slides. The web handler on PassOE, that's also very trivial. It doesn't fit on one slide here, it's on two, but yeah, so all we see here is we get into the handle get method. So PassOE is responding to this get request, and it immediately initiates a response. It sets the content type of the response, it sets the OK status type, adds some headers for disabling caching, because, well, this identity is probably not something we want to have cached. And then we get the reference to the client principal from the session current request info object. So that is built-in functionality in the ABL that you can use on the app server. And yeah, by pure magic, the PassOE implementation is providing us a client principal here. So then the next thing we do, we take this client principal, we verify that the login state is SSO, because that is just the login state that indicates that it's a verified login from a non-OpenEdge source. And then we add that to the body token in this token property. So in the last line here in this screenshot, I export the client principal, which takes the client principal object handle and converts it into raw ABL data. And that's all we need to do to convert the JWT token into an OpenEdge client principal using a PassOE. One thing to be concerned about is when you use the session current request info to get the client principal, you are responsible for deleting that object. You need to be delete objecting it. There's no garbage collector for that. So that's something that we see quite frequently at our customers, that these client principal objects are kept in memory and produces memory leaks. A client principal can be a couple of hundred bytes. So it's not a rapid leaking, but over the course of a day, that can increase the memory consumption of PassOE quite significantly. So you need to delete them yourself. So then further in the configuration of this ABL web application, we say, since the only purpose of this web application is to return the client principal for a JWT token, it only has a single web handler, and basically every URL we issue to that PassOE web application is just purposed to return the client principal. So now let's use ABL and .NET for the same dance. So the reason why we're doing that is because we're aware not every user of ABL GUI applications is already using PassOE. Some may not have any intention to use PassOE. So we want to have an alternative method that is equally secure. Peter and I haven't really finished our assessment whether or not we could be doing this verification of the signature in pure AVL or not. We at least came very quickly to the conclusion that in the environment where we want to use this, the OpenEdge GUI client, we can use the .NET framework in all versions that are relevant to me. I honestly don't care about OpenEdge version 10 anymore. And I'm close to not caring about OpenEdge 11 anymore. But this works fine in OpenEdge 11. We've tested that. So we're using the .NET framework for that. And you'll see in a couple lines of code, the code why. And yeah, it's barely a flow of 3 or 4 different calls into .NET methods. And yeah, whatever we'd have to do with ABL would probably be more complicated. The one thing which is quite easy is understanding the JWT token. So it is not encrypted, it's just base 64 encoded. Base 64 decode is easy in AVL. Then you have JSON objects, you read them using the JSON object model parser, and then you just look at the information that you care about, in this case, the preferred username. But the authenticity, that's a critical thing. So we need to verify the signature. And the first step there is we read from the header the KID, so the identifier of the key. Because based on that, we can find in the JSON web key store the base 64 encoded X309 certificate that was used to sign the key. So that's how this key store looks like. So when you request that URL, and that URL does not require authentication, because everybody should be able to verify that the JWT token is valid. And this is a collection of multiple public keys in this X5C section there. And based on the KID, we look in this JSON array for the right key. And so the bottom red box that shows the base 64 encoded public key that we need to use to validate the authentic key. So first step we need to do is, after downloading the JSON document, we loop through the JSON array of key objects. We look for the one with the correct key ID. The key ID needs to match the one from the header of the JWT token. And when we have that, we take the X5C attribute from the JSON document. So when we do not find one, when we have a problem, then either the server-side configuration of the key store is not correct, or the JWT token has been signed using a key that is no longer valid, or, well, somebody's trying to provide us with a fake JWT key file. So now that we know the key store key, now we use the .NET framework. So in the .NET framework, there are components. So the X509 certificate 2 that imports the base 64 document. We use then that as the input to creating the X509 security key. Then there's a JWT security token handler in the .NET framework. We issue that with a parameter object. One of them is the issuer and the audience, and the key, which is basically 2 times converted from the data we found in the key store. And that returns us this OClaims principal reference if the sign was correct. If the sign was not correct, or there was any other error, it does not return us the principal. So when we get this valid object OClaims principal, then the .NET framework has verified for us the signature of the JWT token. Good. Well, with that, well, where do we stand? What's next? We have that now as a component in our framework. We're in the process of defining that as a separate standalone toolkit that would be a foundation for OpenEdge developers that are not using our framework to use this. We're also working on configuration templates that should make it easier to use the same authentication flow than with other OAuth2 providers. And the ones that we will be looking at initially will be Google, LinkedIn, and GitHub. GitHub, because in the developer community, that is probably a very valid service to do. Yeah, with that, we believe it will make it much easier for OpenEdge developer to use it in different scenarios as well. And then the next thing which we will be working on, we will starting with this in the next couple of weeks, is we will be developing the other side of the story. We will be developing a Java web application that can be deployed on PassOE to turn PassOE into an OAuth2 authentication server. So we implement the authentication flow, which then on the backend uses OpenEdge application logic or a database login to authenticate users exposed at OAuth2. And the use case there is, well, we actually have customers that say, hey, we have a PassOE application that needs to integrate with a portal or whatever. So what do we use for to authenticate portal users? And or how do we authenticate that the portal has access to the PassOE backends? And the methods that we currently use, well, sometimes we have to go back to basic HTTP authentication. Nobody likes it, but it is available everywhere. Sometimes we use certificate-based authentication, which is also, well, works well, but complicated. Nobody likes to deal with key stores more than it has. So the one solution that we always wanted to have there is actually being able to authenticate, to use PassOE to issue us the JWT token, sign it, provide the key store, so that other web applications could use PassOE as the identity server easier. Feels a little bit like something that the authentication gateway from OpenEdge should be doing, but as far as I know, it's not on the roadmap. So then the flow would be seeing like the diagram that Peter had earlier when he introduced OAuth2, a client application, which could be a web browser, an API client, desktop application, authenticates against PassOE, gets the JWT token, and then calls either into the same PassOE, into a different PassOE with that JWT token in the as a bearer token in the authorization header. Good, and with that, I would open it for questions. And if there are no questions, I'm gonna want to point your attention to the next webinars that we plan to be doing in 3 weeks from now. I'm actually not planning to do a proper presentation. Peter and I would like to do a birds of a feather session, which basically just means we invite you to have a discussion with us on everything OpenEdge development related or not. And 3 weeks later, I'm going to be introducing the ability to use .NET Core in OpenEdge. It's a new feature of OpenEdge 12.7. In OpenEdge 12.7, you can use alternatively the standard classic .NET framework, .NET version 4. Whatever. That is there since OpenEdge 10.2, and with 12.7, .NET Core was added to the mix. 3 weeks later, on August the 10th, Daniel van Doorn, one of our DevOps colleagues, will be demonstrating, doing a lot of live coding on building a Docker container, which includes PassOE. You find the dates and the ability to register on our website, consultingrec.com, news events. And the last thing I'd like to draw your attention to, a couple of you are from Europe, but for the American audience here, Pack Challenge Americas is coming back. Woohoo! After 4 years, Tom Bascom is teaming up with the team of the European Pack Challenge, and we're bringing the Pack Challenge to Burlington mid-November, and the goal is to provide an OpenEdge-focused event, purely technical content, 50 plus, probably more in the range of 60 technical breakout sessions over the 3 days, probably also with technical hands-on sessions. Organization is starting. Save the date emails should be going out in the next couple of days. We're actually just waiting for the graphics designer to finish the logo. And the website will be the shared website with the Pack Challenge in Europe. And the split up of the website there will be probably done in a couple of weeks from now. So before we all head out for the summer break, we're hoping to have a lot of details about this conference. Good. And with that, I would like to thank you for your time. It was either late in the afternoon or late in the evening, regarding on your location. And looking forward to seeing you at the next webinar.